Okay, so a topic that is related to exponents, which we just talked about, that is added on to this section. It's really, this is a useful practical skill, especially you all, since you're in intermediate algebra, you're in the STEM track of mathematics, which means most of you are likely to do something involving science, technology, engineering, math. So you're probably going to see this idea of scientific notation if you haven't already. So what scientific notation is it is a nice shortened way to write numbers that are either really, really large or really, really small. If you use them frequently, it's also a nice way to be able to multiply and divide those numbers, but we're not going to get into that part of it. We're just going to talk about writing numbers in scientific notation. So a number is written in what's called scientific notation when it can be expressed in the following form, which I'll try to describe to you, but will probably come into clarity when we do some problems. You're going to have a number A times 10 to some power. And here is the attribute of A. A, or its absolute value, A is going to be bigger than or equal to 1 or less than 10. Now that might be a little confusing. Why? What does this mean right here? What this means right here is that the value of A has a single non-zero digit to the left of the decimal. Now that might not clear it up for you. I apologize if it doesn't, but like I said, when we do a few examples, you will, I hope, get what I'm talking about there, okay? It's important to be consistent in your format of scientific notation so that you can easily compare the magnitudes of numbers. That is kind of the purpose of this. So I'm giving you a moment to write that down. I don't want to jump ahead of you on this topic, which hopefully will be nice and relaxing and a good way to end this unit. Okay, so here goes. First example is 93 million. That's the number of miles from the Earth to the sun. So if you're an astronomer, you don't want to write down all those zeros all the time. You want to write this number in a better way. So here we go. We're going to write this in scientific notation. So you might be saying, okay, Perkster, how do I know what the value of A is? Well, here's what you do. You approach the number from left to right, like we're used to reading numbers. What's the first digit that you bump into? 9. So my value of A is going to be 9.3. You put that decimal behind the first non-zero digit you come to. In this case, 9.3 times, and now you give the magnitude of the number. Okay, it is some power of 10. So all I'm going to do now is I'm going to count the decimal places that I moved my decimal. So I'm going to start over here, and I'm just going to count the decimal places, and I'm old, so make sure you're double checking. So it's 1, 2, 3, 4, 5, 6, 7 places I have moved the decimal. So it's 10 to the 7th. And that's 93 million written in scientific notation. So the number that's right next door on the right, okay, 243 billion. Go ahead and write that in scientific notation for me, please. What's the value of A that you're going to use for this problem? Yeah, 2.43. The first non-zero digit that I hit right there is 2. So I put the decimal right after the 2, 2.43 times, and now I'm going to have my magnitude. It's times 10 to some power. So let's see. How many spaces is that? Yes, 11. So it's 3 here, 6 more, 9, and then 10, 11 to get the decimal behind the 2. So 10 to the 11th power. We okay so far? All right, next one. My next example. Okay, well, that's all well and good for very large numbers, but let's say we're in biology and we just measured the diameter of a bacteria. Okay, so I've got 0.00000. There's 5 zeros there after the decimal, 67. Well, first, let's figure out the value of A. As I go from left to right, what's the first non-zero digit I hit? 6. So A is 6.7. And now I'm counting the places. How many places have I moved this decimal? 6. Make sure you can count from where the decimal is now to where it is behind the 6. That's 6 places. Now, because this is a decimal and it's a fractional unit, okay, my exponent on the 10 is going to be -6, because that makes that 10 fractional. Now, in the last section, I said math people like it when you make the exponents positive, but with scientific notation, that's really the only time that it is usual to keep the negative exponent. So leave it just like that. 6.7 times 10 to the -6. Go ahead and do the exercise that's just to the right. What is my value of A that I'm going to use for this problem? Perfect, 1.31. The number 1 is the first non-zero digit I come to as I go from left to right, times 10 to the how many hops? It's 9 hops, and then yes, since it's a decimal, it's a fraction, it's -9. Excellent, well done, teamwork. All right, the next few problems now, we're just going to go in the reverse direction. Okay, there's nothing new for basically the rest of the section. So now I've got 6.93 times 10 to the 7th. I want to write that out. So here's just how you do that until you get good enough that you don't have to. I'm going to take the 6.93 and I'm just going to write 693, no more decimal. And what I have to do now is I have to count 7 places. So as you're first learning how to do this, you might actually have to draw the hopping, and at some point, maybe you don't. So I'm just going to take and go, okay, 1, 2, 3, 4, 5, 6, 7 places. So that means I need to add in 5 zeros. So the 9300000, that's my 7 places, 10 to the 7th. I'm not going to draw the decimal in because it's at the end of a whole number. It's implied. It doesn't need to be there. Okay, do the next exercise. 4.05 times 10 to the 4th. Write that as a regular number. So this is 4.05 times 10 to the 4th. So I'm going to take the 4.05. I'm going to get rid of the decimal, just write 405. And how many zeros do I need to add on to the end of that? 2. So I should have 4 places after the 4. So 1, 2, 3, 4. There they are. Does that seem pretty reasonable? All right, we're almost done. So if you have any questions, make sure to bring them up. Okay, so now we're just going to do the same thing, but this time with the fractional. So I've got 4.75 times 10 to the -6. Remember, whenever you see that negative, that means that you have a fraction. So it's going to be a small number. It's going to be a decimal. So one more time, I'm going to take the 4.75 and just write 475. But this time, since it's a -6, I'm going the other way. Yeah. So I need 6 places. So the decimal starts out behind the 4. So I'm going to go 1, 2, 3, 4, 5, 6. I do need to keep the decimal this time. And so I've got 1, 2, 3, 4, 5 zeros. Because I got 5 zeros and the 4. Those are my 6 places that I had to move the decimal. Your exercise 2.3 times 10 to the negative 4. So the 2.3 I'm going to write as 23. And then I'm moving the decimal 4 places. So how many zeros do I need in front of the 2? 3. Yep. 1, 2, 3. And put your decimal right there. And there's my 4 decimal places for my negative 4. 1, 2, 3, 4, including the 2. The last problem for you is just write that number in scientific notation. I just don't want you to be confused about a negative in front of the number. Just put your finger over the negative and write the 976 million in scientific notation like you did before. And then once you're done, make it negative. Okay. That negative in front does not affect anything. So what is my value of A when I go to write this in scientific notation? 9.76, that's great, times 10 to the, how many places have I moved the decimal? 8. And then because the original number was negative, you just put a negative out in front. That's negative.